So now let's see the third kind of problem. First one is starting with A, second one is containing A. Now what could be the third one? Yes, you guessed it right. It is ending with A. Set of all strings ending with A. So as usual, identify the language. What is the smallest string that ends with A? Obviously A itself. And what is the next biggest string? So I can have anything in the beginning and it has to end with A. It can be A or B A, right? And what is the next string? A or A B A, so on. Finite or infinite? Definitely it is infinite. Why? Because there is no limitation on the length of the string, or there is no limitation on the number of A's. There is no limitation at all, therefore it is infinite. So now let us take the smallest string and give the finite automata. Smallest string is small a, and this is the skeleton. Yes, if there is a, I am going to accept it. Fine. Now is this a DFA? No. Why? Because states are not complete. Fine. So what happens if I see B in the beginning? If I see B in the beginning, right? So it is nothing but I can even get a string and I can even get A in the end. So even if I see B in the beginning, there is nothing wrong, because I can wait for some time and I can get an A and accept it. So any number of B's, I will be waiting for an A, right? And whenever one A comes, I will think that this is the last A and I'll just accept it. So I have seen lot of B's, and whenever A comes, I'll go to this state and I'll think that this is the last A. I'm hoping that this A is the last A, right? Now let us say I am in B. By seeing this, I am in B. We have reached B under the assumption that this A, whatever we have seen, is the last one in this string. See, we have seen many number of B's, B, so on, and then we have seen one A, and A will assume that, oh, this must be the last A. Under that assumption, it is sending us this set B, right? And now at B, if I get any number of A's, right, still it is ending with A only. So that is not a problem. If I get any number of A's, still it is ending with A only. But if I get a B, it is not ending with A. So again I have to wait for some A. Therefore, if I get a B, I will be waiting for A. See this, how are these states acting is, in the context of this problem, state A is going to accept like this. Any number of B's, it will not do anything. If it sees an A, it assumes that it is the last A and will send to B. Now state B will be final state under the assumption that every A we have seen is the last A. If I get any number of A's after seeing A, still the string is going to end with A only. But if after any number of B's, one A and any number of A's, if I get a B, I have to again go back and wait for an A. So that is how it is being accepted. Okay.